Hi everyone, my name is T is Group 34 and our topic is Smart Cell Product Checkout Systems. First, I will talk about this project background. Self checkout is known as assisted checkout. It is a concept where the customer uses machine to complete their purchase. With the use of the machine, self checkout removes the traditional ways which need the staff checkout and is to prevent the long queues at the market and improve the shopping experience. The customer only needs to grab the products and then they can make the payment by their own. So overall, there has three main types of the self-checkout technology, which is fixed self-scan machines, scan ecosystem, and mobile scan ecosystems. For the fixed self-scan machines, the customer is going to bring their chosen items or products to the specific place and then they can scan the barcodes. Then the customer can pay the items whether with the cash or by some form of the payment cards. Next, the scan ecosystem is a scan gun will be given and the customer scan the barcodes of the items they wish to buy. At the end, the customer is required to go to the specific place and dot the scan gun for transaction, processing, and the payments. Then the mobile scan ecosystem is similar to the scan ecosystem. The main difference is the customer is use their own mobile phone instead of use scan guns. The customer is required to use the phone camera to scan the items they wish to buy, and then the system will record down the products. When the customer have end the buying, they can pay the item anyway instead of go to a specific place. So for the self-checkout system, there are some improvements that can be used in the future. One of the improvements is to implement the computer vision and artifacts intelligence into the self-checkout systems. Currently, the self-checkout system is requiring the customer to scan or capture the items before making the payment and it still consumes time and effort for the customer. Therefore, the self-checkout system can implement the CV or AI so that the system can capture the customer actions while they enter the shopping mall. The sensor will track the customer around and see what they have picked up. Once the customers finish the buying, the customer is free to exit the shopping mall and the payment will be automatically charged. Besides that, implement the self-checkout system is considered as costly nowadays. Therefore, it will cause the happen of thieving and making a lost profit to the business. So, in order to improve the system, a robotic security guard can be used. The robots will look around the people in the shopping malls. Once the robot sees a person embedding a thieving, the robot will warn the persons and will send the message to the system. So the next thing is the problem statements. As the country becomes richer and the life of the average person is getting better, the fertility rate is starting dropping. It is a well-known also in the developed countries. So as a population decline continues, the supply of the variable workforce in the society will decrease and lead to the employers struggle to find a qualified staff. Next, the next problem is the human staff can be unreliable as they can be fall ill and not able to perform their job well. This is very true and can be noticed during the pandemics, where the human interaction can cause the spread of disease and the human staff are higher risk as they will have to interact with many people during their daily works. Furthermore, human staff have a trouble handling high amount of customer and workloads in a short period of time. It usually happens during the celebration events and many customers will visit the shopping mall. It will increase the workload and cause their performance drops and as a result in the long queue at the counters and affect the shopping experience of the customer. Next is the objective of this project. The objective is to develop a workable frames and system adopting the cloud computing mechanics to help the retailer to achieve the optimizations of cleaning service and realize the profit increasement by reducing the human workforce. So that's all for my part. The next is the children. They will continue the presentations.
Good evening, sir. My name is Shujajan, and I will be explaining about our architecture diagram. So this is a brief overview of our diagram. So we are utilizing 9 components from the AWS architecture AWS service. So for the first component, we are using AWS IoT Core. It allows us to connecting the physical devices, such as in our case, we are using IoT camera and the wearing skills to the Amazon cloud platform through the cloud platform to the cloud. So for the second component that we are using is AWS lambda function. So in our system, we are using 3 lambda functions. So for the first lambda function, it will trigger to store the scan item image from the IoT camera before that, and also the wave data to the and it will store into the Amazon S3 bucket. So for the second AWS lambda, it will retrieve data from this one Amazon DynamoDB for comparison, and it will write the detected data to the Amazon S3 and store it into it. So for the third lambda function, it will trigger after the consumer has made the payment, and it will update the database and store the payment data into the Amazon DynamoDB. And after that, the receipt we will send to the consumer email through the Amazon Cyber Notification Service. So for the third component, we are using Amazon Rekognition. It's a machine learning services. It allows us to analyze images or videos without the need of building a machine learning module. So we recognize the image and then we will return result, which is needed in our system. So the fourth component is Amazon S3. So it's basically for us to store the images that we have read and also the data. And after that, we can access the object in a bucket globally, so everyone can access it. So the fifth component is Amazon DynamoDB. It's a non-structured database using NoSQL, and it stores data in JSON format or key value. So it's basically a database which allows us to store the payment data and also the read data. So the sixth one is the Amazon Simple Notification Service version of SNS. So it is basically a trigger when the lambda function is triggered. So it will generate a notification to the service. After that, the notification will be sent from cloud to the user's devices, either through email. It's even supporting SMS and mobile push. So for the seventh component is Amazon API Gateway. So this allows us to create, publish, maintain, monitor, and secure API and SQL. So we are linking the Amazon API Gateway from the payment service to linking the Amazon API Gateway between the Lambda and the payment service. So it will be connected after the consumer's payment. So the payment service will be connected via the Amazon API Gateway to be used in this previous Lambda function. So we're also utilizing the Amazon Cases video series. Our video can be easily streamed from network connected devices. So this is how we after we have a video, we stream using the service and we will connected to the live monitoring. So for the last component they're using is also Cognito. It's basically a security system, a security service which adds the user sign up and user sign and access control, which it also supports signing with social identity providers. So this is how it works. So we are comparing Amazon IoT with Cisco IoT and Google IoT. So basically, AWS IoT is focusing on connectivity, authentication, development, and environment. However, for Cisco, they are focusing on optimizing and utilizing the network. By using machine learning to improve security. They also focus on investing on software and hardware to distribute workloads across multiple nodes and minimizing the latency. For Google IoT, their transportation and smart city solution are taking advantages of the Google Maps platform from the Google, which allowing for a clear visualization of geographic data. So below there are few top use cases for this IoT. So here is the top use cases: smart city for Amazon and the connected vehicles for Cisco and smart marketing for Google IoT. That's all for my part. I'll pass it to a demonstration from Kelvin and Rachel. Thank you.
So, good evening, sir, miss. My name is Louis Kelvin, and now I will do the demo for the system that we developed for the assignment for the course of distributed computer systems. So, in this kind of demo, I will be talking about this section of the entire system here, which is this red bordered part of the diagram here, and we will include shopping cart all the way to the Amazon DynamoDB. So, before I proceed, I'll give a brief rundown in our system. So, imagine a shopping mall. Every shopping cart will be equipped with an IoT camera as well as a weighing scale. So, whenever a customer put a product or item into the shopping cart, the IoT camera will capture an image or the folder of the product and then send it to the AWS cloud, whereas the weighing scale will measure the total weight of all the items inside the cart and then send it to the cloud as well. So at the end of the shopping session, the customer can then automatically check out at the self-service kiosk. So now with that, we'll talk about this we'll demo this simulation of this uploading data. So using this Visual Studio Code, we can simulate the upload of data from this camera, which is this part of the code here, as well as the weighing scale. So in this case, we will use a watermelon image of watermelon as a representation of a product and uploading to this bucket image for recognition. So this part of the code will simulate the upload image to S3, whereas this part of the code will simulate the upload of weight data. So this weight data will upload this card name as well as weight. So this will identify which card that send this data, whereas this weight data is the total weight of all the items inside this card present. So without further ado, let's just demo here. Okay, let's run this code. Then you can see it's successfully. So this part will be here. So once we have simulated here, this image will be stored inside this S3, whereas this weight data will go through the IoT core and then go to trigger this lambda. So this lambda will be this one, lambda get data from IoT, which will get triggered by this AWS IoT core. This is the IoT weighing scale, which is this one here. So once this has been triggered, once this lambda has been triggered, it will read the card name as well as the weight data and then store this relevant data inside this file weightdata.json inside this bucket, image bucket. So we can just go through here. You can see that the latest version of image as well as the weight data has been uploaded successfully. So now, once the weight data has been uploaded into S3, we proceed to the image part here. So the image part will trigger this next lambda here. The uploading of image to S3 will trigger lambda here. So the reason we set this image, you can see here the impact as a trigger, is that because the file size of the image is much more larger than the weight data.json. As a result, the uploading of image will take much more longer time than the weight data.json. So in order to prevent synchronization error whereby the JSON file has already been updated, however, the image file is still in the process of updating. Yes, so in order to prevent this synchronization error, so we set this image file which will take longer to upload as the trigger for this lambda item. So what this lambda will do after being triggered is that it will read the image that has been uploaded just now and then pass it to the AWS Rekognition to identify what is the product inside this card here. So once it has been triggered here, it will send the image to Rekognition, so we can just refresh and then see the result here. So I can see here the latest uploading has been triggered, that has been identified that is a watermelon has been uploaded here. So this is the list, the dictionary list that result has been returned by the AWS Rekognition. As you can see here, it is 99.87% confident that the image consists of a plant, 99.01% confident that this is a melon. As for case our watermelon is right here, watermelon confident that it is 93.49%. So how do we identify that this is watermelon from this whole dictionary? So what we do is that we retrieve this name, and then this is the trick where the DynamoDB come in. So as you can see, this is this part. So once it retrieve the result from this AWS Rekognition, it will read the product list from this Amazon DynamoDB, which is this one product here. So that table will consist of this recognition label. So we are able to compare this label of this product with this this list of this name being returned from Rekognition, and then retrieve it. So not only using this Rekognition label as the comparison, we will use this weight data that have been uploaded here. So as you can see here, we can compare the weight. We can compare this weight data here. So in short, we can use these two variables as a comparison to identify what is the product. So once this has identified that this is a watermelon, it will store this product inside this cart. Yeah, this is where the cart 6 will come into play. It will store this list file inside this inside this bucket of customer cart list. So for example, this bucket represents each of this a collection of all the carts inside the shopping mall. For example, each of this JSON file will represent all the products inside this each cart. So for example, cart 6 JSON will restore the data of all the items inside this cart 6 currently. So you can just download here. So yeah, it may start successfully as a watermelon. So let's say what if the customer add another watermelon into this shopping cart again. So we can just simulate here. So in this case, 2 watermelons will make the shopping cart as a total weight of 20 kilograms, let's say. Yeah, we can just rerun this part here, and then okay, all successfully. You just go back here and then watch the log. So yeah, as you can see here, the latest one, the latest time here. So this is the previous one. Previous one, there's only 1 watermelon. In this case, the newly uploaded image is also identified as watermelon. And then it will show you that the watermelon entry exists in the current in the cart6.json, and thus it will not create a new entry. However, it will simply update the quantity to 2. So let's say what if the customer add another, let's say a banana instead of watermelon. So we could just simulate here banana.jpg. So let's say each banana weight like 600 grams. So this will make the total weight of all items inside it to become 20.6 kilograms. So let's just save it here and then rerun this here. Connect. Okay. So you could just simply go back here and then see. So yeah, you can see that the latest latest simulation show that the AWS Rekognition successfully identified the just now we have image uploaded as a banana, which is it is true in case. So however, so in this case, cart6 previously does not have any banana entry, and thus this is the previous version, and then the code will automatically input a new entry banana here with a quantity 1 here. So we could just go back to cart6 here. Let me refresh this thing. So yeah, now cart6 will consist of a total of 2 watermelons and then 1 banana with the cost updated here. Yeah, so that's all for this part of demo. Thank you. So good evening, sir. My name is Kevin, and now I'm going to demo the later part of our system, which is this red boundary part of this AWS architecture diagram, as you can see here. So this part will include the AWS Kinesis video streams demo as well as the AWS Cognito demo. So in order to use the Kinesis video streams, we are required to set up the Amazon Cognito, which is this Kinesis user pools that we have set up here. So as you can see from here, we have successfully published the live footage data through these Kinesis video streams. So this Kinesis video stream, we can connect any IoT devices. For example, in this case, the device we use is an Android phone, and which the demo application given by the AWS services. So using these Kinesis video streams, you can publish any live stream footage through this AWS cloud, and then allow a remote security and monitoring in the smart self-checkout system. So that's all for my demonstration. And now I'll pass it to my next teammate, Sumechun, who will proceed to demo the later part of our system. Thank you.
Hello, I'm Sumechan, and today I'll be responsible for the part 2 of the demo, which is to send email to customers and update the database after the customer payment. So first of all, I'm using SNS, and this is the topic payment notifications and the email subscribed to this topic. After that will be the database product, and here's the items in the product table. And here's the lambda functions we use to update the data in table, and here is the update item data, and this one is linked to SNS. And for the times, we use the US is 1 time zone. Then in API gateway, we linked those two lambda functions for the API link, and now we can test the APIs for those two functions after the customer payment, for example. And first we test write to DB, which is to update the data. Okay, we update the table, and now we send the email. Okay, message published. And now take a look at the update table, which is the product ID 9. The product name is Energizer battery. And here is the item before the update, and let's refresh. And yeah, this is the updated data. And in email, we received e-receipts, and this is the items. So for example, we want to update the data like stock to 12. We sold 12. And we deploy it. Okay, successfully deployed. Then we run the API again. Okay, updated table, and this is the table before updated. Then refresh it again. Okay, the product stock has been updated. And that's end of my part and end of the demo. Thank you.